All right, good morning, classes. Video here to go over the review for Unit 7, so let's go ahead and begin. Number 1, find a solution to the cube root equations. So find a solution, we need to get x by itself. Again, when we do this, we need to do order of operations kind of in reverse because we are working in reverse, we're working backwards. So we'll start with a little subtraction of 20 here. So we'll minus 20. And then we have 5 times the cube root. X minus 12 equals negative 8. All right. Next, we divide by 5. And so now we have the cube root of x minus 12 is equal to negative 8/5. Okay. Next thing we need to do is cube both sides. That's how we uncube root it. So now we have x minus 12 is equal to negative 8/5 all cubed. All right. And lastly, we will subtract 12. Oh, I'm sorry. We'll add 12 because we're already subtracting 12. Sorry, early morning. I'm sorry, guys. Okay, so this cancels out. We're left with this. So x equals negative 8/5 all cubed plus 12. And so we can go into the Desmos thing and calculate it. So we have negative 8/5 cubed plus 12. And we get 7.904 as our final answer. We could always check our work. By just doing the equation in here. So we have y equals 12 on one side, and y equals 5 times the cube root, which cube root of x minus 12. Let's see where we're at here. Plus 20 on the outside. All right, and so there's our cube root graph right there in green. There's our y equals 12. And we see our answer matches up. Okay, so if you don't want to do the math, you're more than welcome to just take the equation, split it up, do y equals 12 on one side, y equals whatever it is on the other side, and we solve for x, and we see that it's the same just by graphing it. All right, number 2. Write and graph the inverse function of this. So the inverse function, if you recall, we need to flip x and y. So we're going to have x is equal to 1/4 y plus 2 cubed minus 10. You are going to need to rewrite the equation and do the graph. And so let's do the hard part, which is rewriting the equation here. So we got to get y by itself, so we'll plus 10. So now we have x plus 10 is equal to 1/4 y plus 2 cubed. Okay, again, we got to take care of the subtraction and addition first. All right, next, we have 1/4 multiplying by this thing. We need to divide by 1/4. Again, we divide by a fraction by multiplying by the reciprocal, so we'll multiply both sides by 4. Okay, multiplying by 4, or 4/1, if you will, cancels that out. All right, so now we're left with 4x plus 40 equals y plus 2 cubed. All right, And next thing we have to do is we have to cube root the 4x plus 40. So I'll come over here and do that. So we're going to cube root the 4x plus 40. That's going to equal y plus 2. And last but not least, we need to subtract 2 to get y by itself. So we're going to have the cube root of 4x plus 40 and then minus 2 on the outside over there, and that's going to equal y. And again, when we're talking about graphing these things, ladies and gentlemen, what we can always do is graph the original, graph the inverse, and see how they reflect. So, our original function here is we have y equals 1/4 x plus 2 cubed minus 10. And our inverse is y is the cube root, which I'm just going to do to the 1/3 power. 4x plus 40 to the 1/3 power minus 2. All right, so we come up here and we see, okay, here's our original, this purple one right there. And here's our inverse, which is that green one right there, or that black one right there, excuse me. And they should be perfect reflections over y equals x. Okay. So here's our original, here's our inverse. They should be perfect reflections over y equals x. And they are. It's a way you can visualize it if you want to. Moving on. Pause the video at any time if you need to, if you go back and need to slow down. I know I'm going fast, but trying to get through this here. All right, equation of a cube root function that's reflected vertically, stretched vertically by a factor of 7, shifted 10 units to the left and 2 units down. So, our original cube root is the cube root of x right there. All right, reflected vertically gives us a negative on the outside. Stretched vertically by a factor of 7 gives us a negative 7 on the outside. Shifted 10 units to the left and 2 units down. So going to the left, we're going to add. We'll add 10 underneath the root right here. Okay, and then 2 units down, we're going to subtract 2 outside the root there. Okay, so our final thing, y is equal to negative 7 times the cube root of x plus 10. And then minus 2 on the outside. All right. Number 4, find the leading coefficient of the cubic function with roots at 10, 5, negative 1 with a y-intercept at 15, or negative 15, excuse me. So if we have roots at 10, 5, and negative 1, what we're really going to have is we're going to have factors of x minus 10, x minus 5, x plus 1. Okay, those are our 3 factors, and then we're going to multiply by some a number on the outside. So if we graph this x minus 10, x minus 5, x plus 1, we just graph this. So x minus 10, x minus 5, x plus 1. Okay, we graph this, and we see we have a y-intercept here at 50. Okay, so on this graph here, our y-intercept is 50. All right, this one has a y-intercept of negative 15. So what we're going to do is our a value is going to be negative 15 over 50. Okay, negative 15 over 50, which is going to give us negative 0.3. Okay, so this equation is going to be negative 0.3 times x minus 10 times x minus 5 times x plus 1. If we choose, we could also do a regression with this if we wanted to, and using the x10, the 5, the 1, and the y-intercept at negative 15. So if we were to do that, let's say we decided to do that here and do a table. So let's say we do a table here. So we have a root at 10, 5, negative 1, and a y-intercept at negative 15. All right, so we have these things here. We want to do a regression. We have y1 approximately equal to ax 1 cubed plus bx1 squared plus cx1 plus d. All right, and our leading coefficient is going to be the a, and we see the a there is negative 0.3, which matches up our thing. Okay. Alrighty. Number 5, talking about factoring out the function right here. So we have 6x cubed minus 31x squared plus 25x plus 12. So first we want to find is any obvious roots. Okay, then we could use synthetic division to do that. So obvious root, we see we have an obvious root there at 4. Okay, positive 4. So we can go positive 4 and synthetic division this out. We have 6, negative 31, 25, and 12. Pull down to 6, okay? So we have 6 times 4 is 24. Add those, we get negative 7. Negative 7 times 4 is negative 28. Okay, 25 plus negative 28 is negative 3. Negative 3 times 4 is negative 12. Negative 12 plus 12 is 0. Okay, so our first set of factoring here, we have one root at 4, so we have x minus 4 as a root. Our other root is going to be 6x squared minus 7x minus 3. Okay, so now we got to factor this purple thing out. Okay, we're going to do that. First things first, we're going to multiply 6 and a negative 3, which we get negative 18. And we need two numbers that multiply to negative 18 that add to negative 7, which in this case would be negative 9 and 2. We're going to use the negative 9 and 2. I'm going to erase this thing here to give myself room to split that negative 7x up. Okay, so we have 6x squared minus 9x plus 2x minus 3. All right, and now we're going to factor this thing out. So 6x squared minus 9x, what goes into both of these things? Well, 3 goes into 6x squared and 9x, and x goes into both of those things. Okay, we pull a 3x out, and we're left with 2x minus 3. And then what multiplies into 2x and negative 3? Well, the only thing that does is 1. So 1, and then we're also left with 2x minus 3, which is what we're supposed to have. So what this means is we have our 2x minus 3, parenthesis. Our other parentheses, what's going to be on the outside, which is 3x plus 1. and we still have our x minus 4, so that's going to multiply outside there, okay? So those three parentheses are the three factors of that function, 6x cubed minus 31x squared plus 25x plus 12. Alrighty, a couple more problems here. Number 6, piece of cardboard is folded up into an open roof box. The cardboard is 20 by 27. Find the maximum volume of the box. Again, this is where we do, we're going to have 20 minus 2x. Okay, that's going to be one side, and then 27 minus 2x is the other side, and then x is the height. We'll graph that. And is asking for the maximum volume, so the volume is a y value. Okay, so 20 minus 2x, 27 minus 2x times x. I'll be right there. Just wait. All right, so 20 minus 2x, 27 minus 2x times x. So here's our graph trying to find the maximum volume. So it's going to be our maximum y value. It's going to be up there at 914. Inches cubed. All right, find the value of x in the equation right here. So again, I'm not going to go through the whole thing. So we'll minus 60 and minus 60. So then we're going to have 7 times x minus 2 to the 7 halves is 700. Okay. Next thing we got to do is we have to divide by 7. So we divide by 7. So we get x minus 2 to the 7 halves is equal to 100. All right, now to get rid of the 7 halves, we got to raise both sides to the reciprocal of 7 halves, which is to the 2/7 power. All right, so we have x minus 2 is equal to 100 to the 2/7 power. Okay, and lastly, we got a minus 2. So x is going to be equal to 100 to the 2/7 power plus 2. All right, last problem here. Write the equation of the transformed root function. All right, so we see that we're going to have a transformation there. We went over by 4 and up by 9. So we went to the left by 4 and up by 9. All right, and now, we talked about finding the vertical stretch. Well, let's look at the rise over run. So from our point right here, we go 1, 2, 3, 4, 5, 6 and over 1. So 6 over 1. So our vertical stretch is 6. Our vertical stretch is 6. It's an increasing function, so there's no reflection or anything like that. So our function is going to be 6 times the cube root x plus 4 and plus 9. That's all there is to it. There's your review. Let me know if you have any questions, and best of luck to you guys. Thank you.